Okay, so here they want us to simply circle the irrational numbers on this list. And really, what does this mean? Well, it means circle numbers where the decimal representation, right, the decimals, if you try to represent these numbers with decimals, the decimal representation would be what? Well, the decimal representation would be infinite, what they often call non-terminating. So the decimal representation would just keep going on and on and on, and it would have no pattern, have no, repeating pattern. So this just means that you can try and represent the number with a decimal, but when you try to do this, you'll never get a terminating decimal and you'll never get a repeating pattern. So for example, an example of an irrational number, right, is something like, let's say, 3.1415926535, and then you might find, okay, what happens after this? 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1, 2, 2, 3, 1, 1. You keep going, and even if there is some kind of pattern, like say it starts to climb, so it goes 1, 2, 3, 4, 5, 6, 7, 8, and so forth, right? This has a pattern where the decimals start to actually follow this pattern as if you're counting up, right? We go up to 9, and then 1, 0 over 10, and then 1, 1. That's not a repeating pattern, even though it is a pattern. So the decimals go on forever without any type of repeating pattern. Another thing here that we're saying is that, oh, this is for irrational numbers, sorry. Irrational numbers, not only are the decimal representations infinite without a repeating pattern, the fraction representation is impossible. So that's the idea. The fraction representation, it cannot be done. Right? A simple fraction is one where you have one integer over another. So by fraction, we're saying basically a positive or negative whole number, z or integer, over another one. Right? If that was what you're calling a fraction, which is what we call a simple fraction, and you're trying to do that to represent an irrational number, you'll find there is no fraction for any irrational number. So that's the idea. All rational numbers have simple fraction representations. All irrational numbers do not. Now, what does all this mean, and how does this relate to square roots? Well, with square roots, if you take the square root, right, of a number, let's say you take the square root of a whole number, and what you're getting is, right, some decimal. So it's a whole number plus some fractional part. So for example, square root of 45. Well, what is that between? Well, I know that 6 squared is 36. I know 7 squared is 49. So radical 45 is between there, right? It's 6 point something. It's pretty close to 7. So it's 6 point something. In other words, the whole number is 6 and some fractional part. When this happens, when you have a radical like this, it's guaranteed to be irrational. That's our first irrational number. And again, this only works if you're taking the square root of a whole number, like 45. Same thing is true with 46. Radical 46, the answer is between 6 and 7, right? Really close to 7, but still some whole number and a fractional part. The square root of 47 is also irrational for the same reason, and so is 48, excuse me. Square root of 49 is rational, right? Because that's just 7. 3.14, well, this goes back to our other definition before. Here's a decimal. It terminates, it ends. So it goes 3.14. And that is what? That's not pi, it's just a representation. It's 3 and 14 hundredths, right? So you can write that as a mixed number and then write it as a fraction. 314 over 100, same thing. If you can find a way to write your number as a fraction, then it is rational. Pi is our famous irrational number there. And also we have these other numbers. Well, the square root of 0, that's just 0, because 0 times 0 is 0, so it's rational. Square root of 1 is rational, because 1 times 1 is 1. But the other two numbers, 2 and 3, are also irrational, because they have roots, right? That's what we're talking about here. Roots that are whole numbers plus some fractional part. All right, thanks.